Module 1, Lesson 23, Problem Solving Using Rates, Unit Rates, and Conversions. In the last lesson, we looked at constant speed problems. Today, we're going to look at work problems. All right, so I can statement. I can solve constant rate work problems by calculating and comparing unit rates. So once again, we're looking at, instead of speed, we're going to be looking at work, and we'll discuss here in a second more specifically what is meant by work. So if work is being done at a constant rate by one person and at a different constant rate by another person, both rates can be converted to their unit rates and then compared directly. So just like with all of our other unit rate questions, our goal is to take a rate, get it down to the unit rate, so that we can make a comparison between rates. So just like shopping with money, just like speed, we are trying to get things that are comparable. Now, when we talk about work, that means things that are done in a certain time period. So it could be a rate of running, it could be a rate of swimming, it could be just about anything that happens we could consider to be work. And we'll see through some of these examples what we're talking about. And it looks like I left the learning target slide off. I'll have to add that afterward, but our learning target is obviously working with unit rates, which ties back into ratios and equivalent ratios. All right, so we're going to take a look at this example here. Suppose that on a Saturday morning you can cut 3 lawns in 5 hours. Now hopefully we have looked at enough rates now that you can say there is a rate, and you can see that your friend also has a rate. So we have some work being done here. In this case, very real work, cutting lawns. And the question we're trying to answer is, who is cutting at a faster rate? Before we go any further, I would like to unpack the rate here. I see that in this first rate, I have a unit rate of 325, and I have a rate unit of lawns and hours. And in the second one, I have 528, and I have lawns per hours. And within each of these, I then have some kind of ratio, 3 to 5 and 5 to 8. And I could, if I chose to, represent these with tape diagrams. And I'm doing this because I don't want us to lose the connection with rates are connected to ratios, and that we can represent what's going on here with tape diagrams, double number lines, tables of equivalent ratios. We can tie this all back to what we have done with ratios, and that's important to me. So we've got our two rates here, and we're making a comparison. We're trying to figure out who's at a faster rate, but we've got you who's cutting lawns, and we have an information about 5 hours, and here we've got an information about 8 hours. We've got different numbers of lawns, so it becomes a little tricky to figure out exactly who is cutting these lawns at a faster rate. So what we can do here is use some of our unit rate information and thoughts here, and we can scale this down to 1 hour. And we can scale this down to 1 hour, and then we have something comparable. When they're both at the same number of hours, now we can compare. So if we're going to scale this down, I've got this 5 here, and I'm going to divide by 5 to scale down to 1 hour. And so up here I am going to divide by 5 to scale down to 1 hour. And I'm going to find out that a single hour is 3/5 of a lon. And over here I've scaled down using division by 8. And I see that I've got 5/8 of a lon in 1 hour. So now I have some fractions. I could, if I wanted to, convert these to decimals, which might make it a little bit easier to compare. And I find out that this 3/5 is 6/10 of a lon in 1 hour. And I've got this 5 divided by 8. And I find that 5/8 of a lon in an hour is 6 25 thousandths. So I could at this point compare these two decimals and indicate that the friend is cutting the lawns at a faster rate. So that's one way that I could make the comparison. And in this case, in this comparison, I have actually simplified this down to a per 1 hour rate. Now we do have our other strategies that we have used. I could scale up. I could take the 3/5 and I could take the 5/8 and I could ask what is the least common multiple. And so I could scale this up by multiplying by 8 and find out that the denominator would be 40 and the numerator would be 24. So in 40 hours, I would cut 24 lawns. And in 40 hours, my friend would cut 25 hours. Sorry, 25 lawns. So here I, instead of scaling down, I have scaled up and made a comparison. So all of those strategies that we have used with ratios, we can apply to rates. And we have, in our rate, we have our unit rate, and we have our rate unit. And we're applying all of the same strategies. And if we asked for a very specific comparison, we could say that my friend cuts 1/40th of a lawn more per hour, or we could do a little subtraction here and say they cut 25 thousandths more of a lawn per hour. All right, let's take a look at another one here. So suppose you own a restaurant and you want to do some advertising, so you hire 2 students to deliver takeout menus around town. Now, one student, Darla, she delivers 350 menus in 2 hours, and another student, Drew, delivers 510 menus in 3 hours, and you had promised a $10 bonus to the fastest worker, and because time is money. So who gets the bonus? Well, we need to have a comparison. Who gave out the most menus for their given time? And hopefully at this point, you have said, hey, I've got a rate here. Hey, I've got a rate here. And I need to make a comparison. And, well, let's take a look here. We've got 350 to 2. And that's menus and hours. And we have 510 to 3. And this time, I'm going to just leave this as my one set of labels because they're both working with the same rate unit. And I like this connection that I've got all the menus here, and I've got all the hours here, and now I need to set up to make a comparison. And we've looked at a couple of different ways here. I could scale down, So I could take this 350 over 2, and I could say, all right, I need to get down to 1 hour, so I would divide by 2. And 350 divided by 2 is 175 menus per hour. And I could take the 510, and I could scale down, dividing by 3. And I could find 510 divided by 3. Pretty sure it's 17. 17 times 3. 170 menus per hour. And I would find that Darla has actually delivered the menus at a faster rate. She's delivering 175 menus per hour, where Drew is only delivering 170 menus per hour. So Darla is faster by 5 menus per hour. So I have scaled this one down to find a solution. I could also scale up. I could find the least common multiple. I could have 350 to 2 and 510 to 3, and least common multiples, so I count by 2's. And I am looking for the lowest number that is on both lists of multiples. So multiples of 2, multiples of 3. And I am saying what is the lowest number that's on both of them, and that's 6. So I could scale so that they are both at 6. So I would be multiplying times 3, multiplying by 3. And I've got 350 times 3. There we go. 0, 5, group. So in 3 hours, Darla would deliver 10,050 menus in 6 hours. And we'll scale up multiplying by 2, and I would find out 1,020 in 6 hours. So once again, I can see that Darla is delivering at a faster rate. So I have extended it and said, okay, what if they both went for 6 hours? Who would deliver the most menus? And here is the setup out of the teacher materials. And you can see that they have set it up in the manner in which we already looked at. All right, so here we've got another comparison. We've got a cheetah who is running 60 feet in 4 seconds, and a gazelle that is running 100 feet in 8 seconds. And the question is, who's faster? Well, once again, we're comparing feet and seconds, and the cheetah is 60 to 4, and the gazelle is 100 to 8. Now I could, and this is just the way that my brain ran, I could scale this up right here to be 8 seconds, and I would find it's 120 feet in 8 seconds compared to the gazelle at 100 feet in 8 seconds, and I can say that the cheetah does run faster. However, a frequent question that you will encounter is, how many more feet per second is the cheetah running? So we do need to be able to get this down to feet per second instead of feet per 8 seconds. So we would want to make sure that we are able to scale and get these down to a feet per 1 second. So I'm going to have 60 over 4, and I've got 100 over 8, and I want to scale down to a 1, which means that I will have to divide by 4, and I want to scale down to 1, which means I need to divide by 4, because I divide both of these by the same. So if I want the 1 second rate here, I have to divide it by 4. And 60 divided by 4 is 15. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So another way to look at this would be with a tape diagram. And on the bottom of my tape diagram, I could say that this is my 4 seconds. And I want to find 1 second, so I'm going to split it into 4 pieces. And here is my 1 second. Now the 4 seconds was equal to 60 feet. And I can see that the 60 feet has been divided into 4 pieces, and each of the units in here would be 15. So a tape diagram representation to see what's happening with the scaling, because these things are locked together. They're tied together. The 60 feet is equal to the 4 seconds. So if I want to scale down to 1 second, I will cut it into 4 pieces, which means the 60 has been cut into 4 pieces. And I find out that the cheetah is running 15 feet per second. And let's take a look at that tape diagram again. And I've got the gazelle running 100 feet in 8 seconds. So I want to take the seconds, the 8 seconds, and I want to get it down to 1 second. And I think I need one more. There we go. One, two, three, four, five, six, seven, 8. Okay. And the 8 seconds is tied to the 100 feet. So when I took the 8 seconds and I cut it into 8 pieces, I have done the same with the 100. I have taken 100 feet and I have divided it by 8. And I've got a little division going on here. And I find out that the gazelle is going 12 5/10 feet per second. So I have scaled down, but this time to understand the scaling, I have actually connected it to a tape diagram. I've actually been able to look and say, how does this look visually, instead of just abstractly. Abstractly, of course, it's going to set up like this. We've got 60 feet in 4 seconds, and we're going to scale down, so divide by 4. And we're going to scale down, divide by 4, and we get 15. And we've got 100 feet in 8 seconds, and we're going to scale that down, divide by 8, scale that down, divide by 8, and we're going to find out 12.5 feet per 1 second. But I know for many of the students, this is still very abstract, so I really like connecting that with the tape diagram that we have used so much this year. All right, example 4. What if the units of time are not the same in the 2 rates? What will this mean for the rate units? So the secretary in the main office can type 225 words in 3 minutes. And the computer teacher can type 105 words in 90 seconds. Is it still possible to make a comparison? Well, in one of these we have words per minute, and in the other one we have words per second. If we are going to make a comparison, we are going to need to get to the same units. We are either going to have these minutes be turned into seconds, or these seconds are going to have to turn into minutes. If we're going to make a comparison, we need to be comparing the same things. So yes, we can still compare the unit rates, but we're going to have to do a little bit of work before we do that. Now, it's a really good thing that in the last lesson, we talked about how to convert units. So for example, I know that I've got 3 minutes, and I want to end up with a number of seconds. And I can look on my conversion chart, or I can use my knowledge, and I can say that I know there are 60 seconds in 1 minute. So the minutes will cancel out, and I will find out that there are 180 seconds. So now I have a rate of 225 words per 180 seconds. And I can compare that with 105 words per 90 seconds. And now I can do some scaling to make a comparison. I could scale them down to 1 second. I could double this one right here and have 180 seconds and have 210 words per 180 seconds. And I can then see that the secretary in the office is typing at a slightly faster rate. They're typing 15 words faster per 180 seconds. And of course, I could also scale this all the way down to 1 second. So absolutely, we can still make comparison. I could also turn the seconds into minutes. For example, I've got 90 seconds, and I want to end up with minutes, and I want the seconds to cancel, so I need a rate of minutes per seconds, and I have 1 minute per 60 seconds. So the seconds will cancel, and I will have 90 60ths minutes, and I could simplify that down to 9/6, and I can do a little bit of division here. Although I'm thinking I did something wrong here, I need to step back. My brain is screaming at me. No, I'm good. 9 divided by 6, 1 times 6, 3/6, which is 1.5 minutes. And now I can compare minutes with minutes. So yes, we can still make these comparisons, but we might have to do some unit conversion along the way. So it's useful that in the last lesson we worked on those unit conversions. Well, I guess it was 2 lessons ago. All right, so taking a look here at the lesson summary. So rate problems, and that includes constant rate problems, meaning things that are happening at the same rate. They always count or measure something happening per unit of time, per minutes, per seconds, per days, per hours, per millisecond. And we put the time in the denominator. You'll notice that the rates that we looked at today, it was always feet per second, miles per hour, words per minute. The time unit winds up in the denominator. Sometimes the units will have to be converted. Sometimes we're not looking at the same thing. We might have words per minute and we might have words per hour, and so we have to do some unit conversion to get them to both be the same. All right, so taking a look at the I can statement, I can solve constant rate work problems by calculating and comparing unit rates. So remember, constant rate is we have something happening over time. Something is going on here. Lawns per hour, chores per week, naps per day. Something happening over this period of time. And we can solve these constant rate work problems by finding unit rates, getting it to a per one, and then making the comparison. And of course, I left the learning target slide off, and we've looked at working with unit rates, finding unit rates, making comparisons. So this concludes Module 1, Lesson 23. If you've got any questions, make sure you talk to your teacher and make sure you complete your problem set.